This is the birthday problem, and it says, how many people do we need in a class to make the probability that two people have the same birthday more than one half? For simplicity, assume 365 days a year. So it says, so the probability of two having same birthday is more than one half is the same as the opposite. So if two have the same birthday, then three can have the same birthday as well, because if there's three with the same birthday, then these two have the same birthday and these two have the same birthday, and so do these two. So it's almost like saying probability of at least two having the same birthday. And if you know when there's an at least, you can say the opposite is when nobody has the same birthday. When everybody has a different birthday, then it's the same thing as having at least two with the same birthday. Not the same as, but it's the opposite. So the opposite of these two, this is like an equal sign. If you look at it, I'll do it normally. Opposite of probability of nobody sharing birthday is, now we're saying it's the opposite, right? So we're going to say it's less than one half. This one is much more solvable. So we can just say, okay, so probability of nobody sharing a birthday. So let's say there's n people, right? We're trying to find that number n. The first person can have any birthday. If there's nobody in the room we're trying to consider, the first person who enters that room can have any possible birthday and it'll be allowed. So, and that's 365 over 365. The next person can have one less allowed birthday. Let's say the first person's birthday was January 1st. Then the next person can have every birthday besides January 1st. So that means they have 364 possible birthdays allowed, or 365 minus 1 over 365. And this is a person 1, person 2. Person 3 can have 365 minus 2 possible birthdays out of 365. Now what about person n, the last person? As we can see, the relationship between this term and the person number is that it's one less, right? We're going to do like basically doing like minus 2 plus 1 here. Or here it's 365 minus the person number plus 1. It can be like written like this, minus 3 plus 1, right? And this can be minus 2 plus 1. We're just going to keep it as just minus 1 for ease, minus 2. So then this person, the nth person, we just said can be 365 minus person number plus 1, right, over 365. And what's the operation in between them? What's the operation we use here? Well, it's saying the first person can have this many birthdays, and the next person after that can have one less birthday, and one less birthday, and one less birthday. And if you know when you have the and not symbol, but the and operation, I guess, you can what you do with the terms in between them is multiply them. When you have the or, it's add. When you have the and, it's multiplication. So it's this term times, 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 right? And so when you do this, and we have n people, the denominator becomes 365 to the power of n. The numerator becomes 365 times, and this is 364, times 363, times, times 365 minus n plus 1. And we said it was that this term, or that this like left side of the equation is less than 1/2. And what you do now here is you solve for the n such that it makes this equation have a probability of less than 1/2. To solve for n, it's like kind of like messy. You have to like do like some summations and inverse logs and all this stuff, and you can like approximate it at that point. But to solve for it like accurately, you have to do guess and check. That's not really the important part of getting this solution. If you were asked this in an interview, they would probably like ask you to stop here. They just want to see you get to this formula and like derive the solution. But if you want to like guess and check, like plug in the values of n to see what works, just know that the answer is going to be n equals 23. So that's actually surprising. It only takes 23 people to have a probability that two of them having the same birthday be more than 1/2, which is kind of crazy to imagine, but yeah, that's the answer. And yeah, that's all.